talk about something I enjoy every day, which is learning and programming, but in this case, of course, with Java. But I want to start with one thought that comes to my mind, and that is, if you think about Java as a language, one of the questions, you may ask some people is, what is Java? And of course, we know what Java is. But if you ask the question, what is Java to you? I think the answer is going to be different depending on whom you ask, because Java is a language that's different for different people in here. Some of us develop enterprise applications with it. Some of us develop web applications with it. Some of us use it for teaching purposes. Some of us like to learn. But somebody asked me the question, what's Java to you? And I was kind of surprised. But the answer was almost instantaneous out of my mouth. And that's when I realized what it actually means to me. And to me, Java is the passport to the world. And this really surprised me because, I'm a little guy and I get excited about things, as a lot of people know. But part of that excitement is I learned something, and when I learn something, I can't keep it to myself. I want to share it with people. And all of a sudden, I found myself being in random airports around the world. And I would be in maybe, Riga, Latvia, or maybe in Antwerp. And I'll be, suddenly, somebody would come to me and say, hey, Java. And they see a shirt I'm wearing with Java logo. And then the next 2 hours at the airport just goes by like a minute, because you can talk about concurrency and garbage collection and everything in between, and how exciting it is to really talk about it. In fact, this reminds me of one experience I would never forget. I was in London to speak at a conference, and Neil Ford, good friend Scott Davis, and Ted Neward, the four of us decided we want to go have dinner at a restaurant. This was completely coincidental. So we go to the restaurant, and we sit down, and out of pure coincidence, my good friend Brian Slett and his wife, Kristen, and a few other people were in the neighboring table. And then, of course, we said hello, and we sat down. And for the next, I'm not even exaggerating here, for the next hour and a half, we argued if checked exceptions are a good idea or not. And after this 1.5 hours, we have not still done. And Brian finished his meal, and Brian and Kristen left. And then as they exited, Kristen came back all the way alone to our table and said, hey, I want to say thanks. And we looked at her and said, why? And she said, now I know exactly what my husband does when he travels with you all. I have nothing to worry about. So, and all we could do was talk about checked versus unchecked exception. But that's the beauty of what we do, is we get so excited about things and we go into the details. But I said Java is a passport to the world. And I'm almost in tears when I say this, because you notice that my name here, I decided to, on social media, I decided to put my name in Ukraine, because that's a country I love. I've been there several times to speak in Java conferences. The last was in Devnexus, Ukraine, and before that in JJE conference. And I want to really express my love for the people of Ukraine. I absolutely think that they should absolutely, thank you very much. Yeah. And I think the world needs to be a better place, because to me, honestly, I say, Java brings us together. And I'm almost in tears when I say this, because this is not what we want to see. And I see our brothers and developers going through all the trouble they are going through right now. This is just not acceptable. I hope we'll be a better place in the world for the future generations to really look at it. So what I want to talk about today is the excitement around Java, and what is it really awesome about it. And that's what I want to really focus on today, to share some of the thoughts I have with Java itself. So, of course, we hear about Agile everywhere. And I go to companies and they say, Venkat, we want you to know that we are Agile. And I always say, I'm so glad we can get that out of the way. Now let's talk about what you do. And then, of course, they talk about things they do. And it came to me as a surprise very recently, by the way, about, when you talk about Agile, I believe in sustainable Agile practices, the engineering Agile practices. But you should have seen my surprise when I came to know, what Agile is for a lot of organizations. But I want to say there are 2 words that I hate the most. And honestly, I mean this. The first word I hate the most is the word called Scrum Master. I don't know why. When somebody comes to me and says, I'm a Scrum Master, I say, I'm really sorry to hear that. Like, why? This was not meant to be. You can go and look at the Agile Manifesto. Nowhere they said you will serve as a Scrum Master, right? So somewhere something went wrong and we got in our head. I always give this example. I'm a big fan of movies. I love movies. But every time I see movies, I have to think about programming. But one movie I really enjoy watching is the movie on, where Moses comes down, and says, hey, Joshua, you take care of the people. I hear voice up the hill. I'm going to go up the hill, right? And he goes off up the hill. And then I love watching 10 Commandments over and over. And so Moses has gone up the hill, and poor Joshua doesn't know what to do. And these people are like, hey, what do we do? We are in this foreign land. What do we do? And then a few scenes rolls by, and they collect all the jewelry they have. And then they melt it. And then once they melt it, they build a statue. And then they worship the statue. And I always pause right there and say, that's Agile today, right? Somehow we have gotten to the point where we love ceremonies. We love rituals. And why? Because ritual allows us to hide from real work. And we can just be in the safe net of, oh, did you do your stand-up today? And everybody's so happy, right? But what is it that we need to really do? Oh, that comes later. The other word I really hate the most is velocity. And it's like, go faster and faster and faster. Like, for what? Why do we need to go faster? They don't care what we do. And so, to me, I believe in sustainable Agile practices. Am I getting the results? Am I able to produce results? That's what I really care about. And it came to me as a surprise recently, by the way, that it took me many years to realize that TDD stands for Ticket-Driven Development. And thus, every organization is doing TDD today, right? But the point really is, are we really building software that's relevant? Are we building in a way it's sustainable? That's what I really want to focus on. So, and from that point of view, I want to relate this back to Java for a little bit. But what is really Agile development? Let's not lose sight of it. It's not about being a Scrum Master. It's not about stand-up meetings. It's not about the rituals. Then what is it that really means that we want to be Agile? And I would say, to me, Agile development really is feedback-driven development. That's what it is all about for me, is to do feedback-driven development. I'll share with you one experience I would never forget. This was back in 1993. And you know what 93 was? This is a time before cell phones and all those good stuff that we enjoy today. And I wanted to go to Grand Canyon. I've been there quite a few times. I love that place. This was my very first trip to Grand Canyon. Unlike a lot of places in the world, you can't see Grand Canyon from a distance. It's a hole in the ground. So I started driving, and I was driving for about 2 hours, and all of a sudden I had this doubt. Am I going in the right direction? And what do you do when you're in doubt? You ask for help. That's a good thing to do. But I park my car, I get down, my wife and I, and we're looking around. There's nothing around for 360 degrees. Had a choice. I can turn around and start driving back where I came from. I can drive for about an hour or two and say, hey, was I going the right direction? And they could say, yes, you were. And I can turn around and drive again. Or I can keep driving for however long it is, and what if I'm in the wrong direction? And you may say, oh, come on, Venkat, how reckless of you. Why don't you have taken a map with you? Oh, my dear goodness, yes, I did have a map. And you know what, that map, the map, I put it on the hood, and I'm looking at it. But that map was missing one thing. Anyone knows what that is? The blue dot, right? The blue dot was missing in it. And today, I can start driving, and I can look at it, oh, you're going in the wrong direction, turn around. And to me, that blue dot is all about Agile development. So it's not about where you want to go, but how far away are you from it. And to have that feedback loop is enormously powerful. And when I'm able to see that feedback loop and say, here's where I am, here's what I'm delivering, here's what the customers are doing, are they happy with it, and what can I do to improve it? And so to me, the Agile development is all about being feedback driven. That's what I'm really towards in general. And now let's talk about Java in that regard and see how that actually relates to Java as a language. And I'll be absolutely honest about this. If you ever heard me speak back in 2007, 2008 timeframe, I'll be absolutely open and honest about it. I was that person on the other side of the picket line, constantly complaining that Java is not evolving. I used to speak in conferences and say so much about how Java is not relevant, how it's not changing. I'm not even kidding with you. I actually have saved these because these are beautiful things to save. I've actually got an hate email saying, Venkat, I hate you because you hate Java. And the point is, but that's basically my expression of my views because the language is simply not moving. And I was very frustrated back in time, and you can look at the evolution of Java back in time. It was extremely slow in terms of things happening. And when they did happen, you always question the features. Are they really helpful? Are they useful? And for example, generics, and then we have type erasures with it. Auto-boxing, is that good thing or bad thing? And we keep wondering about these things, and Java was moving at a very slow pace. And this was very frustrating for a lot of people, and some of them were vocal as I was, and of course, what happened since then is the question. But to my surprise, and to a lot of other people's surprise, to me the game changer was Java 8. And I remember very clearly, saying to myself, I don't care that Java has Lambda expressions. I've used Lambdas in other languages, why do I care? And I remember one day, I said, let me just take a look at it. Let me just see what it is, what it has. And I'm not exaggerating when I say this at all. I was sitting at my desk, and I was just looking at the APIs, I was playing with things, and then I looked at Lambdas, I said, okay, big deal, I can use an arrow, I can use a thing, okay. Then I looked at Stream, and I stood up at my desk. Literally, I stood up, and I toppled my chair, and I was just staring at my computer. I said, okay, this is going to change everything. And I was so excited about Stream, I'm not exaggerating this at all. I started writing the book on Java 8 that moment. This was about 2 to 2.5 years before the release of Java 8. My book was the first one to be released on Java 8. We released it the day Java 8 was released. But when I was writing the book, I wrote something in the book, and the editor called me on the phone and said, hey, Venkat, are you sure you want to say something like this in a technical book? And I said, yeah, but I live in Colorado. And she thought for a minute and said, yeah, you're right, and she hung up. And what I said in the book was, Lambdas are the gateway drug, streams are the real addiction. But to me, true, and Mark is, Rabel is laughing here, so we're neighbors. So essentially, the idea really is, Lambdas are great, but to me, the real power of Java is in streams, because the lazy evaluation is a game changer. What I distinguish between what is considered to be functional style code to a functional programming, it's a leap, and that efficiency. And without lazy evaluation, we're not going to have efficiency. And without efficiency, nobody's going to use it. And so the developers behind the language did not want to rush through and deliver something. They really took the time and said, there's a hard problem to solve, but we're going to do it really well. Then came the next surprise for me. If they had simply used an inner class, and if they had simply implemented using an inner class, like a lot of other languages did on the JVM, imagine what would have happened. More garbage you create, the more garbage you collect. So performance would have suffered immensely. So they said, no, we can't be doing the same thing. And to me, the true innovation in Java was the use of invoke dynamic to implement the Lambda expressions calls. And to me, that was brilliant. And so when I started seeing not the syntax of the language, but when I started seeing the semantics of what they did, I was convinced that we are onto something. And to me, honestly, that's what turned me from saying all those things about Java and singing the praises and say, this is a language that's going to be really powerful. And I metaphorically say two things. One is, Java to me was on the deathbed, and suddenly you see it jogging on the streets, and you're like, whoa, how did that happen? But I always say, with what they did in Java 8, I always say, my analogy to this is, or metaphor to this is, that Java came very late to the party, but they came with amazing desserts. And this changes everything in terms of how we can make use of it. So I had the deepest respect for Java since then, and that only has gotten better over time. But if you look at this particular picture here, this is talking about the release of Java. And if you look at it, Java 5 was in 2004, September. Java 6 was 2006, nearly 2 years and 2 months later. And then you note, or 3 months, and then you notice the next one was Java 7 in 2011. That's almost 4 years after. And then, of course, Java 8 was 3 years later. Java 9 was 3 years after that. But here is the reason. You may ask the question, but why has it taken so long to release every time it's 3 to 4 years? Why is that? Well, you know exactly why it is. Because when your boss comes to you and says, how's it going? What do you say? I'm almost done, right? And what does it almost done mean? 3 years later. And we have the pressure, right? And what happens though is, when you try to synchronize things and say, this will go into this release, and when all these things are part of this release, we are ready to release it. But guess what? Some things are ready, some things are not ready. And so what do? Let's wait for the whole thing to go. And what is that called? It's called pre-planning. And what did Agile Development tell us? Pre-planning sucks. Don't do it. Now, of course, I'm not suggesting, hey, we're Agile, no planning. That's a disaster in its own. But the whole point of Agile Development is adaptive planning. You want to adapt your plan based on the reality. And so what they were doing back then was counter to all of these. And they said, here's what the release will be, next release will be, and boom. And until we have all those things, we cannot release it. Keep pushing, keep pushing, keep pushing. That clearly did not work. And so at some point they said, maybe we should really rethink about it. And that change really started in Java 10. And Java 10 was the last such release in March 2018. And as you know, Java has been on 6 months release cycle since then. And now, of course, we're moving at a really fast pace. It's no longer the snail I talked about, and it's really accelerating really nicely. But then you say, wait a second though, 6 months release cycle, huh? Well, we all have been bitten by this in our own companies, isn't it? People tell us we are Agile, and you say, what does that mean? Well, you're on a sprint every month, or you got something to release every few weeks. And you're like, are you kidding me? And how do we do all this work in this time and release it? It's pressure that we are all on. And so anytime we hear this fact that we're going to have a shorter release cycle, we're in a panic mode because all our poor memories rush to us, isn't it? And so we always ask the question, is that really practical? And I want to really emphasize this one thing. Java is not being developed on a 6 months cycle. I think that's one of the things we need to really keep in mind is Java is not being released on a 6 month cycle. If you look at just one feature, for example, the one feature in Java 10, which was the type inference, it took them at least 5 years to develop that feature. And if you look at a lot of other features that have come since then, it's been taking. But what is really more interesting though is they've not just been releasing the 6 month cycle, they put it out and say, hey, we want your feedback. Try it out, see how it works, and tell us what you think about it. And when the feedback is, it's not quite adequate, they don't release it. An example of this was in Java 12. We were looking for raw strings, and 2-3 weeks before the release, we were like, oops, where did raw string go? Well, it eventually came out as a text block, but there was a rewrite of that because we understood better about what it is, and so they decided to go back and rework on it. But I want to give you an example of this in terms of what this really means. A few years ago, I was going to turn 50, and they say people do crazy things when they turn 50. I was on a train ride from Krakow to Torun in Poland, and I finished speaking at the conference, Devox, and then I was going to go speak at the user group in Torun. And I was in the train ride, I was just thinking about it, looking out the window, and suddenly realized, hey, wouldn't it be so cool to speak at 50 Java user groups for my 50th birthday? And I immediately texted my wife and said, hey, I've got this idea, hoping she would say, you crazy man, be quiet, come home. And she said, what a great idea. And now the next thing I know is I'm texting, the leader of the group, and I'm saying, hey, I've got this thought. I want to start this as the first one of the series. And suddenly I blogged about it and said, hey, I'm turning 50. I'd like to speak in 50 user groups. And very quickly, I'm very thankful, humbled, and that's why I said Java is the passport to the world. Around the world, I got invitation to come and speak at the user groups. But one of them is Jose, who is here in this conference. He emailed me and said, hey, I know you're doing this 50 user groups, but the Paris Java user group is also reaching a milestone of an anniversary, 10th anniversary. Can we combine your 50th birthday with Java's Jug's anniversary? And I was absolutely delighted. I would be delighted to come over and speak. And little did I know it was going to be on top of the Eiffel Tower. So the actual meeting was on Eiffel Tower. This is actually inside Eiffel Tower at the very top. You see that stage in the middle, and I'm absolutely indebted to Jose for making this happen, other people in the Java user group. But then, as part of this, one of the things I committed to was to speak at the Switzerland Java user groups. And they hold the group meeting in different cities every single day. So I was going to speak Monday through Thursday over there, or Monday through Friday rather, and then go to Germany and speak in Mannheim on that Saturday. And I was thinking, my goodness, I'm going to speak in 6 user groups in 6 days. I don't know how I'm going to handle this going through 6 cities. And I land in the airport in Zurich, and Marcus Hirlon comes over and says, hey, welcome to Switzerland, and he gives me the little folder. And Marcus is an amazing person. That's one of the things I really enjoyed in these interactions is not just the language, but the people that are part of the community is just absolutely amazing. And Marcus gives me this folder and says, here you go. And I said, what is this? And he said, well, these are your train tickets for the week. And you can take these trains and go from one city to another and speak at the user group. We took care of everything for you. And of course, I was a little apprehensive, right? A country I'm not familiar with, how is it going to be? And I found out that the ticket he got me for the train the train leaves at 10 past the hour and 40 past the hour every hour. And suddenly I realized, wait a minute, I can get up in the morning, do my work for a few hours, go on a nice run, have a nice breakfast, read a book, and then when I decide it's time to go to the next city, I'll just drag my luggage and go to the train station, and I will have a nice conversation with somebody in the train station, and I'm like, if I want to take the train now, I can. If I don't, I can take the next one in 30 minutes. And I cannot tell you how relaxed I was. I have a flight tomorrow, and I've checked the flight 5 times already. And I keep thinking about it. I got to make on time. I'm doing extensive planning. Because if I don't make that flight, I won't get home on time, and I got other things to take care of tomorrow. And I'm always thinking about that. But when there's a trip that you can take every 30 minutes, you're like, it's not a big deal. The cost of failure is so less. And it got me thinking, what an amazing idea. A train leaves every 30 minutes, and you can leave on any of the trains when you are ready. And this is exactly what the folks behind Java nailed it. And they said, we got a train leaving every 6 months. And you can release your version of the application feature or language feature anytime you are ready. You don't have to synchronize with other people. If you're ready now, you can release it within the next 6 months. If you're not ready, you can release it anytime you want to. One question that I heard Mark Reinhold answer earlier was, when will Project Loom be released? And his answer was very simple. He said, when it's ready. And I truly love that answer. Because we try to pretend, we try to say, oh, we want to put a release date. But really practically, we are putting hard effort. This is engineering. We don't know the outcome. And in fact, one of the things I will emphasize is, I tweeted this a few months ago, and I said, those who compare software development to construction business understand neither one of them. And the reason is, even in construction, this is true. I'm actually building a house, and the builder is extremely practical, one of the best persons I've ever known in my life. And the builder says, look, I cannot promise you a date ahead of time because the weather conditions are really bad. And we have supply chain management issues. So I'm going to give you a deadline when I can commit to it, and don't ask me for it until then. And it's just an eye-opener to say, wow, there are actually people who are sensible in this world, right? And we have to be practical to really approach it, and that is something really important to think about. So like I said, this release cycle really removes the burden. And as a result, we have something coming out every 6 months, and when something is ready, it can be shipped in the next 6 months. And then, of course, if it's not ready, we can wait and ship it in the next one. And so that becomes a very incremental release. So what does that really mean? So Java is not being developed on a 6-month cycle, but Java is being released on a 6-month cycle. And to me, that is incredibly powerful. So what does that really give us in terms of the ability for Java and for us, the programmers who use it? Well, the first thing for the development of Java is it greatly mitigates the risk for the language itself, because they don't have to now wait for all these features they promise ahead of time to come together to release it, and so they don't have to delay the release. That reminds me of one experience I had. I won't mention the name of the country right now because it'll reveal the company as well, but somewhere in Europe. And I was teaching a course for a group, and I had a person who was a lot older than me. Maybe he was nearing his 60s at the time. And he said, hey, we've been doing this Agile stuff. And I was kind of looking at this like, my goodness, the person who's nearing 60 years of age obviously has a tons of experience with several things, including waterfall. This Agile stuff should be really different. So I was very curious. I asked this gentleman, hey, I want to know, how do you feel about it? And he said, you mean about this project and the way we do Agile? And I said, yeah, how do you feel about it? And he said, I love it. And I said, whoa, you love it? Can you tell me why you love it? And he said, look, I've been writing code for a very long time. And when I used to write code, I would implement all these features, really get excited about it, and I would finish it, and it would be years before anybody cared to use it. And then eventually somebody would use it, and they would ask me something about it. I won't even remember that I wrote it. Now, I write something, and within weeks, people are asking me questions about it. They show me they are using, and you got to know how empowering that is, to know that you actually are valuable and your work is used. And I thought to myself, what an amazing concept here for somebody who's of that experience. I won't say old, but that experience. He is able to see how rewarding it is to see your work being actually used. Because why do you write code? So it can be used after all. And what good it is if it's not being used. And that is the first step in terms of Java itself. These developers who are putting their hard effort into writing these features, they're able to release it and see it being used sooner than later. Secondly, they are putting it as a pre-release and saying, give us your feedback. Tell us how it's working for you. Tell us what you want to change. And that feedback loop I mentioned is absolutely rewarding. What is it for me as a programmer? The benefit to me is I am not having to read and understand a lot of things in one sitting. It is like the steps I can take one step at a time, and I can keep going. And so it's very incremental. And that means it's easier for me. Among all the other things I have to spend my time on, I can learn just one feature every 6 months or 2 features every 6 months. That's a very nice incremental development, so that it's easier for me as a person to adapt to these technologies as well. And in that regard, they've done some really amazing things. And I want to spend a little bit of time showing a few things that have absolutely excited me in the past couple of releases. So let's say I want to call over here a little output. We'll call this as process, if you will. And I'm going to pass a value of 1. And I'm going to also call this and pass a value of, let's say, a hello right there. But we all have written code like this. So I'm going to say over here, in this case, I'm going to say this is a process function which takes an object which is an input, let's say, over here. And why would I even receive an object? Oh, maybe it's a messaging system, and I'm getting different types of messages, and I want to process them. So imagine I cannot really put a specific type, or even if I can put a specific type, it may be a message type, and then I still want to know what I'm receiving. So there may be an inheritance hierarchy I want to work with. But in this case, I'm going to simply say whatever to begin with and say I'm returning whatever for both of those. But within this, I'm going to say if. And I'm going to say input is an instance of. So instance of, if it's an instance of an integer, what do I want to do? I'm going to say return, let's say got a number, let's say in this case. So I can say I got a number. But on the other hand, if it's input is an instance of a string, so I'm going to say instance of a string, what do I want to do? I'm going to say, oh, return got a string, let's say. So we'll start with that little example and run the code. So it tells me I got a number or got a string, so that's a good thing so far. But I want to then go a little further with this. And I want to say, hey, I want to give a little bit more information about this. So I'm going to say got a string of length. And I'm going to say over here plus length. But what in the world is length? So I'm going to say int length is equal to input.length, and I'm going to call that function. Will that work? No, I hear. What's wrong with it? And the compiler says, hey, you cannot call length on input, and why not? Because there is no property called length on the object. So what do? You then say, oh, okay, and you put a parenthesis string like so, and then you put a parenthesis like this, and then you call that method, and the compiler is like, good for you. Now, quick question, does anyone remember what this feature in the languages is called? You call it casting, I call it punishment. Think about that for a minute. Would you have a nice conversation with somebody? You see them walking out the building the previous evening, and you ask them, where are you going? And they said, oh, I'm going to watch this movie I've been waiting to watch. Oh, have a good time. The next morning, you meet them at breakfast, and you ask them, hey, did you go to the movie? And they say, yes, I did. And you say, how was it? And they say, how was what? And you're like, really? You're going to do this to me? Because how was it? It means the movie, isn't it? And you're going to roll your eyes and say, never mind, have a good day. And you're going to walk away, isn't it? But what did Java do? You went to Java and said, Java, I got a question for you. Uh-huh. Is that a string? Yes, it is. What's the length of what? And so my question is, do you work for the compiler, or does the compiler work for you? Java compiler comes to you and says, how's it going? I'm trying. Try harder. I'll be back from lunch and check on you. And you're sitting and coding. Well, unfortunately, these things don't make us productive. Because rather than solving a real problem, you are saying, compiler, how can I help you now? Could you please get this code working? The compiler is like, I'm thinking about it. I'm not sure if I'm in the mood today, right? This is called ceremony. And ceremony really damns us, right? Stuart Halvey wrote a beautiful blog about it. If you Google for it, he said ceremony damns us twice. Essence really is important. So Java says, hey, maybe we should really evolve a little bit, and they call it pattern matching on instance of. I like to call it as a smart casting. Well, Groovy calls it smart casting, Kotlin calls it smart casting. I love smart casting. So what can we do? You say, hey, I've got a string coming in here if you don't mind. So in this particular case, you can say stir.length, and you can write the code like so. So you're saying, hey, I checked for the type, and when you are satisfied with the type, give me a variable of that reference. str is not a reference to a new object. str in this case is just a casted type to that particular object, but do that in one shot. It becomes a lot easier. But you can take this idea and you can go with this even further really nicely. And this, again, is something I really like seeing. A few years ago, I ran into Brian Getz, and I was having a chat with him in Belgium, and he said, oh, you like pattern matching? I said, oh, I love pattern matching. I've used this in many languages. I really, really like pattern matching. And he said, yeah, I agree, that's a good feature, so I'm going to give it to you in 3 installments, he said. I said, Brian, what do you mean 3 installments? He said, well, we want to make a journey towards it. We're going to turn the switch into an expression first, and then we're going to turn it into a pattern matching syntax, so every step of the way, we're going to keep improving on it. So, and that, to me, is an incremental feedback-driven development is very, very powerful way of doing things. So in this particular case, you can take this idea and say, hey, this is great, but rather than doing this, why don't we do the following? Return a switch. And on the switch, we can simply put an input, and we can turn this into an expression. Oh, by the way, if you want to quickly know if it's a statement or an expression, I'll give you a little clue. Is semicolon or no? That's an easy way to identify it. So a switch expression requires a semicolon. A statement doesn't. So if you're looking at a switch expression, the switch expression, of course, can return, or you can save that into a variable as well. But if you really think about it, think of statement versus expression. I'm not a fan of statement at all. And in fact, this came to me as a realization, call me silly, but I realized, hey, in functional programming, we don't want to encourage mutability. If that is the case, what do I expect to see in functional programming languages? Really, expressions and not as many statements or no statements at all. And as it turns out, the more functional a language is, the more expressions it has and not many statements. The problem with statements are statements will lead to side effect and statements will lead to mutability in general. Expressions don't have to. So rather than writing a switch statement where you may have to mutate variables, you can turn it into a switch expression. And when you make it a switch expression, you can just return the results. But added benefit, you don't have to worry about the break statement because it's a natural way to complete a branch and exit and not accidentally go into the next one. That makes the code a lot safer, less error prone as well. So I'm going to say default, and the default is going to be whatever right here. But I can say a case, integer, and I'm going to say this is going to be got a number. And the code becomes a lot more concise here. And then I can say a case, a string. And maybe in this case, I can say stir, and I can say got a string of length. And in this case, of course, I can simply say of length, and we can just add, this is going to be stir.length in here. I can call upon that particular function and get the results of it. So essentially, in this particular case, we are able to turn that into a switch expression. And we can also use the pattern matching of the instance of within that as well, and except without using the word instance of. So you're basically saying, hey, as you come in here, tell me if this particular object is of type integer, take this path. If it's of type string, take this path. But you can go a little further with this as well. You can go back to this code and say, hey, I'll have a value of 1, or I have a value of, let's say, 5. But if I want to treat 1 special, I can say we'll say got 1, for example, in here. But what I can do is, I can say I is equal to 1. I can do a little bit of expression, and this is called a guarded pattern matching. And you say got 1 versus this one is got a number. But the compiler is pretty much watching over your shoulders as well. If you were to flip this, you notice you get an error. And the reason is, this is going to take all the route for the integer. You will never get to this path. And so the compiler says, maybe you made a mistake. You want to go back and check it, and gives you an error. So it's looking out for you. So the code is less error prone. This is called dominance, what I just showed you. And it checks for the dominance as well really nicely. So what does this mean to us when we write the code? You know, I program in about 15 different languages. And the reason I say that is to emphasize that I'm not good in any one of them. But I love programming languages. And I believe in this idea of writing code and then making it better and refactoring. But I remember one thing very clearly in all these experiences with different languages. I would write code, and then the test will be passing, and I look at my code and say, oh my gosh, this code is really nasty. I need to really make this better. And almost always, I would go look for something like pattern matching in the languages. And because that really made the code more expressive and more concise. I did that in Erlang, I did that in Ruby, I did that in Python, and almost any language I program in, I always reach out for. And then in Java, I would say, okay, I wish I could do this. Well, I don't have to wish anymore because it's possible now. I can write code in a very concise manner. And the benefit is, why? Because the code you write today, which is maintainable, is the future you thanking you, right? One day when you look at that code when you're tired, you're saying, good job. Writing that code back then, it's understandable. Or, I have this theory, by the way. You know, as I'm getting older, I always say, oh, it's hurting over here. Oh, it's hurting over here. And I used to think it's just old age that's kicking in. But then I realized one day, it's not the old age. It's the programmers looking at the code I had once written. and cursing me every time. And they look at this and say, who the heck wrote this book with this particular code? I'm like, ouch, it's hurting here. I think they have a voodoo doll. They kind of screw it a little bit, and let's see Venkat get hurt, right? And so you want to really write good code, because at least if it's not you, others are going to be thanking you for the code you write. But this becomes really expressive, and that's really powerful idea. So we can start writing code like this very quickly as we migrate into it, and the code becomes less ceremonious. And we are removing all that clutter, and as a result, the code begins to read like the problem statement. We are able to write code more concisely. But to me, the reason I'm getting really excited about this is, what is programming? And I want to say sincerely, have you ever known anyone who says, I'm going to write code, and then they just sit down and type code, and then they say, I'm done, and they walk away, right? No, absolutely not. We don't write code like that. The way we write code is we try something, and you're like, it doesn't work. And you try something else, it doesn't work. You try something else. Programming is a series of mini experiments. And every single day, you are experimenting with your code. Nobody sits down and says, I'm going to go and write code and walk away, right? And we try and we try and we try different things, and you try to make things work. And this is one thing my wife has told me. And she said, Venkat, you are the politest person I know. You never use bad words. And I said, yes, sweetie, thank you. And she said, but. I'm like, oh, there's a but here. And I work from a basement. And she said, but I would come down to basement to get some stuff once in a while. You don't know this because you're busy writing code. I said, okay. And the type of stuff you say when you write code, it's unimaginable. And I said, oh, I'm sorry, that's called programming, right? Because when you're writing code, every emotion comes out, isn't it? Because you want this code to work. And so I'm definitely very different among people than code, thankfully, I would say. But that's what programming is. We're trying to make the code work, and you're experimenting with it. And to me, when you're experimenting with the code, the least you want in your way is the ceremony. And when that gets out of your way, it gives you that power to try new ideas. Otherwise, you're like, I'll try this some other time. This is really, really getting hard to write because all this noise is getting in our way. That's one benefit you get out of this. The second thing is to go back to think about a few other features. We got a beautiful feature of text blocks. And text blocks is actually a multi-line string, and you don't have to go through the ceremony of writing this code. For example, if I were to take this code right here and call a method, let's go ahead and say in this case, some method greet I'm going to say here, and I'm going to say Devnexus over here, and I want to really call this particular method called the greet method, and I'm going to say here's a string, and I want to say this is going to be taking a string. Let's go ahead and say city or a name, whatever I want to pass here. Well, in this particular case, what do you do? If you want to create a message, you say string message is equal to hello there, and then what do? You say message plus equal to, and then you say how are you? And then you go back with more, and you say plus equal to, and you write more code. Would you put this on your resume? Would you say, I have 20 years of experience using plus equal to, right? This is the code you hide from humanity. You don't want anyone to see this ever. And for those of us working from home, this is dangerous business. Because you're writing code and a kid walks in, you got 10 seconds to hide the monitor. Otherwise, what happens? The kids look at this and say, that's what you do for a living? I really wish people told me this. I am the last Subramaniam programmer. Because I did the mistake that I wish really people told me, don't do this. I took my kids, put them on my lap, and I said, sit down here, kid. I'm going to code. And the kid is sitting on my lap as a baby and hitting the keyboard once in a while. I love the variable names they create. And then what happened? As they started growing a little older, suddenly they looked at my code and they looked at me and said, Dad? I said, yes, that's a code you write? And I said, yes, dear. And my son said, Dad, don't worry. I'll grow up and I support you. You don't have to do this for too long, right? So this is what happens when you write code that is ceremonious. The next generation don't want to take what we do. And as a result, this is not going to be really fun. But we don't have to do this, thankfully. What we can do instead is we can go here and say, hey, we can do a multi-line string readily. And we can then say, of course, return the message when you're done with it. And you can say, for example, hey, hello there. And you can say, how are you? And you can write more lines of code, thanks for, being here. And so on and so forth. We can write that code very easily without much difficulty at all. And it's a little hard for you to see from there, but the compiler was so smart, it even removed that indentation, knowing that indentation really, we didn't mean it. This is called smart indentation. And I love it when compilers are sensible and they do what is really best for the programmers rather than the other way around. And so the smart indentation kicks in really nicely in here. And basically, in this case, you can say a string.format, for example, a message, and I can put the name in here and return the string as I would please to. So this becomes incredibly easy to write those things. And imagine for a minute, you want to really produce a XML output, or you want to produce a JSON output. So what do you typically do to put XML or JSON as an output? Well, typically, you are not going to sit there, I hope, and type XML or JSON all by yourself, isn't it? Because that's not a good use of your time. So if I replace the spaces with a tilde, what's it going to do in this particular case for the message, that is, right? So you will notice that everywhere there's a space, you see a little tilde. But I'm going to go here and add a few more spaces here, as you can see. Now, why am I showing that? Because if you're going to be using an XML or a JSON data, you're not going to sit there and type it. What do you do instead? Use this best technology humans have ever invented called copy and paste. You're going to copy it and paste it, right? And when you copy and paste it, what's going to have? All these extra spaces. How annoying that is if it is there. Once again, the innovation of text block, you can see the tildes don't appear in the end of hello, how are you? Because the compiler said, hey, you probably didn't mean it. That's just a copy and paste. I'm not going to force you to sit and remove all of that, right? That's another ceremony. Just leave it there. We'll take care of it. We'll clean it up for you. That becomes really nice. So that's another incremental step. And again, where the compiler is working for you rather than you having to work for the compiler. And that's a really nice step in the right direction. But then you say, all right, this is great, but here's a problem. I have created a plugin architecture, and my users can use my plugin. They can use a factory to get an object from my system. They can then pass the objects to my application code, and when they pass the object, we're going to process it. Oh, for that, of course, I've defined an interface. All this is going really well. And your application, this actually happened for a client of mine, actually. So you receive an object which conforms to an interface, and you're doing some processing with it. But all of a sudden, your application chokes up and dies one day. And you're like, gosh, what just happened here? Why doesn't my application work? And that's when you discover one of the users of your application generously decided to implement one of the interfaces. And you're like, gosh, I didn't mean for you to implement that interface. That was meant to be used, but not to be implemented. But how do you enforce that? How do you tell people, you will use the interface, you can use a factory to get an object from me, but don't go off to implement those interfaces because the application requires these classes to be implemented? The short answer is you can't. The longer answer is you can try and fail, but you really can't. So it becomes really hard to enforce that in general, and everything you come up with is going to be, this of course is called Scotch tape-driven development. You put more tapes on it, right? And the more tapes you put on it, the more it kind of becomes hard to maintain. But what if the language can really help us to provide that for us? So here is an example just to think about it for a minute. So I'm going to go ahead and create a traffic light .java where I say sealed interface, and I'm going to say traffic light. And in this case, that's my interface, but I'm going to say final class let's say I have a red light that I'm going to create, which implements, let's say, the traffic light. And similarly, I'm going to create two more. I'm going to create a yellow light in here, and also maybe a green light as well. Now that I created these three classes, but notice I marked it as a sealed interface. So what is a sealed interface? Well, you can create a closed hierarchy, and you can say, look, this is my interface. You can use the interface, but don't go off implementing that interface. Only these classes are allowed to implement that interface. So in this particular case, I defined three classes that implement that interface. I go back over here to the code, and I'm going to simply ask the compiler, is this okay? Are you happy with this? Is the question I'm going to ask in here. And the compiler says I'm happy. But then I'm going to say a class called a broken light, why not? Which implements, in this case, the traffic light like so. And if I were to do this, what does the compiler say? It says, sorry, you're not allowed to do that. Hey, why not? Because that class, that interface can only have three inheriting classes. You're not allowed to add it. Now, obviously, as a default, those were in the same file. That makes it easier to implement. But that's not required. You can also have them in external files as well with some restriction. But you can use a permits class to really say, my interface will permit these classes to implement. And sealed classes and sealed interfaces can be really powerful from the point of view of modeling. And by doing so, what are you doing? You're not only making the code expressive and easier to implement, you're also making the code easier to, less error prone as well, and that becomes really nice. And of course, I didn't even mention the records. Records remove a lot of ceremony in the code, but records at this point is less code. And you may say, yeah, that's awesome, but is there anything better for it? And this is where the charming feature comes in. I'm a person who gets excited about things, right? And when I get excited, I talk about it or I tweet about it. And there was one morning I was writing a piece of code, and I got really excited. So I immediately tweeted saying, today's tweet is sponsored by destructuring. And within a few minutes, Brian gets replied saying, I neither confirm nor deny if Java will have destructuring. And I replied saying, I think I know what the answer is now, and I cannot wait for it. But he goes on and describes different types of destructuring right in that tweet. And it was very educational to just read not only about destructuring, but the thought process he's having. And guess what? Imagine now mixing records with destructuring, and when it comes into pattern matching. So all of a sudden, you're receiving a record as an input to a function, and you can just slice away the properties of the record in a very concise syntax. So that is one of the other things that really excites me. And that is not only each one of these ideas and implementations and concepts are interesting and useful in their own, but the combination of them where they interplay is just absolutely amazing as well. So that brings us to the question, what is the evolution of Java? And I'm going to say this is one of the things that Java does very differently. And I have the deepest respect for languages and the authors of the languages. I may make fun of the languages from once in a while, but that doesn't mean in any way I don't respect what they do. But Java has other issues that it needs to tackle in the world. And that is, Java is one of the systems, one of the languages, one of the ecosystems that is the most widely used in the language. The developers of the language don't have the luxury to put something in and say, oops, that's not something they can afford to do. They have to be very meticulous in adding things into the language. But the reason is very simple. You may say, but you don't understand. That language can change. But that language doesn't have the constraints that Java has. And that is when 10 million people use your language. And out of the 10 million people, 1 million people know where you live. You have to make decisions very differently. And so they don't have the luxury of just throwing things together and walking away. So the developers behind the Java language are using 3 things to decide if a feature will come into the language. It's not infatuation. It's not what are they shopping for. It's quite the opposite. It's a very, very thorough engineering practice. They look for three things to really bring in. The first thing is, will a feature be useful for Java programmers? Now think of the word agile with respect to that. You think of your users first. They're not about, hey, would it be cool to do something? They're not creating work for themselves. The first question they're asking is, will this be useful for Java programmers? Is this a way that Java programmers would benefit from? So they're looking for what will be relevant and useful. The second thing they ask is it feasible to implement it? And what is the cost of implementing? And a third question, is it useful? Is it feasible? And the third question they are asking is, by adding this feature, what are we going to make harder in the future to implement? We always think of what is there that's going to make it harder to do, but they're asking what in the future will become harder to implement this. And so if a feature, by adding it today, is going to make something else in the future really harder to implement, maybe this is not the time for it. Maybe this is not the approach for it. So they are taking really good time to think about this and evaluating it when they decide to implement a certain feature. So with that said, many talk about doing agile, and we hear this everywhere we turn, but Java is being agile. And that's what I have the deepest respect for when the group of people get together and say, we're going to do this hard thing because this is sensible to do. We all heard so many oppositions to this when they started going through the cycle. But when you really look at it, you say, wow, they're not talking about being agile, doing agile, they are being agile. And to me, that is refreshing. And I think it's a great time to be using the language. I hope that was useful. Thank you very much.